Welcome to Practical AI, everybody. My name's Jeff Northrup. This is Peter Lynn. Today's topic is about the Pareto principle or the Pareto distribution in AI models. Peter, a recent article we saw says that only about 13% of models that are made reach production. Explain to us why that is and what we can do about it.
Sure. So the article that we were referencing was a study, and the basics that the article covered was getting the data is hard. So even if you're a big company, like something in the Fortune 500, usually the data is kind of divided up among different groups in a company, and there are what's called silos, and each silo has ownership of that. And usually, from our experience, one silo doesn't want to give access to other silos. And so this is infighting of like, no, this is my data, you can't use it.
So you mean it's literally in political infighting within a company, like certain department or a certain architecture group doesn't want to give any information to the security team or whatever.
Yep. Yeah, so that's kind of the enterprise space. But in the startups and in research, the data you want oftentimes just doesn't exist. Now there are efforts like Lion, which is a European group that is creating an open data set from the web. But that data, I mean, there's a lot. There's like billions of records in it. But for someone to make a data set for their particular use case, you have to go through and mine out what you need. And even then, for many use cases like medical stuff, you can't use it, because if some data got leaked into a public data set, it's violating privacy and regulation rules. So like in the US, HIPAA rules are important. If someone's medical image, like an X-ray or a CT scan, got into the web, you can't actually use it, because if the person requests you remove it, you can't remove it from your model.
So you're saying that sometimes AI models are trained on data that is private, and then therefore the model is useless?
Well, it's not useless. It's just if someone comes and sues you, you're in trouble.
Well, maybe it's not useless. Maybe a better word is unusable.
Yeah. Yep, it's unusable.
Okay. Okay. So we also have then probably, if 13% of the models are the ones that are successful, 13% of the startups are probably successful as well, or something, a smaller percentage than the greater number of startups. So this means there's a lot of money flowing into stuff that isn't working. Is all of that money wasted, and is all of it kind of dependent on this data problem?
A lot of it is wasted because a lot of startups never get past the point of having enough data, because they're following this model of like, we just need to get enough data to build models, rather than like, let's take a really small problem, get enough data just for that, and then gradually grow it. So an example of that would be like Google Lens. Google Lens is their image search, where you can take a picture of something, Google will process it and find other similar things. So that was launched in 2017, but for the first couple of years, it wasn't really good. In fact, it was worse than the old reverse image search.
So what happened to Google Lens? Is it still being used?
So it's still being used, but it's not popular. And in 2022, they made it the default search for image search to get more people to use it, because people weren't actually using it very much.
Work better now that they've had a year's worth of forced search?
So that they've I don't know. And Google doesn't publish the results of like whether or not, but they're trying to monetize, right? Because they've spent, so it's been public for 5 years, so that it means they probably spent another 5 years training that first version that was launched in 2017.
Okay, so you've got a data problem. This is kind of the common theme throughout AI. There's just the amount of data to train properly and get the results you want apparently doesn't exist. But shouldn't startups know that going in? Even Google, shouldn't they know that this is going to be a problem based on how AI models train?
Right. So they do know, but what are your options? It's like you want to build something and you have this problem of like you need enough data. And because we don't know how to actually train small models on tiny amounts of data, like less than 1 million records, people just go, well, we just got to start. And then we just got to build up our data set until it gets to billions.
So two questions. And one is, what would get us to tiny data sets to be able to train on smaller data sets? And then, the follow-up would be, then how do you help, a young and upcoming, ML engineer to kind of chart his path, his or her path through this data problem and this ML sort of 13% problem?
Yeah, that's a great question. So I think no one has the answer, but there's a couple of things people starting out should do is one, try to focus on a really small problem and then just build a small data set and try to really understand, is this working or not? Um, and then we need a lot more researchers to kind of focus on, can you interpret the model? Because right now the big kind of barrier is we don't understand what the model is doing, what all those weights are doing. So until we get to the point where we can really understand what the weights are doing and really can interpret what it's doing, it gets really hard to actually build small models with small data sets.
Okay. So this brings up another question that has come up, and you've talked about this before, and you just mentioned it again, this idea of small data sets, or sorry, smaller models. ChatGPT and others are kind of built off of this monolith model, which is like super big models doing all this work. And um, it seems like there's talk about, building smaller specific models. And here's, Jeff Dean from Google kind of talking about this a couple of years ago. Where's the AI community on this? And if this is something that is somewhat important, why is ChatGPT architected as just a monolithic silo as opposed to using something similar to this, a smaller model?
Great question. So the reason why OpenAI just scale things up and build a huge monolith is that we don't actually know how to build small models that can do the same level of accuracy. One of the recent interviews with Ilya at OpenAI was when they trained GPT-4, it was much bigger, and they discovered that like, oh, making the foundational core of it, the actual language understanding part better, meant that everything else that it hung off of that just improved dramatically. And so right now, it is one huge monolith. And everyone knows that we need to make it more components, smaller pieces that you can then recombine to create new things much quicker, easier, faster, better, and it's more flexible so that if someone makes a better module that is, like 2 times better, you can just plop that out, drop the new one in without having to like rebuild a whole entire thing.
So on the one hand, you're encouraging people to do smaller models with smaller data sets. On the other hand, if I'm hearing correctly, the industry doesn't know how to do this well. So how do you bridge the gap for a young modeler, an engineer, on how to do it in a way that is meaningful and productive and a good use of time?
So that's a tough one because right now it takes engineer probably 5 to 10 years to get enough experience to really get to the point where they understand, like, okay, this is what it's doing. And so one is we need better tools so that you can actually crack open a model and go like, hey, what's happening? Like, what's in layer 3? Like, what are the weights and what are the weights doing? Like, is it doing this thing or some other thing? So today, when researchers say we need to interpret what the model does, what they're trying to is we need to understand what all these weights are doing. And so that's an active area of research where most of the research shows that what we think it's doing is not actually what it actually is doing. And so we need more people working on that.
So apart from getting involved in research on the interpretation of models, your suggestion is do your best to create small models with small data sets, learn with the community, and you'll have better success in the long term as AI gets to the point where it's doing components and building components of models into a supermodel as while it moves away from the monolith model.
Yeah, because right now, all the universities, all the big corporations have a small group of people, but they're all marching in the same path. Right? They're all on the same road because the corporation says, this is the road we're taking, and we're all going to do the same thing. But what we actually need is we need 10 times the number of people all doing different things. Because then that's when we like come across a discovery that go like, oh, wait a minute, this is how we make better models. Because right now there's too many people all thinking the same thing and doing the same thing, and that's not really going to get us there. What we need is we need everyone, more people to do it and try different crazy ideas. And from then we'll learn like, oh, okay, this works, this doesn't work. We combine these two things, it works a little better, it works worse.
Well, it's a fascinating problem and a fascinating topic, and I'm sure one that's going to emerge more and more frequently as people dissect this, because it sounds like we've got a monolithic mentality building a monolith model.
Yeah.
Right.
Yep. Yeah.
And we need more of a marketplace.
Yeah, and there's parallels in software. Like in the 80s and 70s, there's a few companies like IBM, Oracle, building and selling software. And they would have new releases every 3 or 4 years. When open source started in the 90s, it was chaos because anyone could do anything and share stuff. Well, now we fast forward to 2023 and open source is the dominant model because through that intermixing and community and trying different things and trying bad ideas and breaking things, we arrive at the better solution faster.
Yeah. Always comes back to open source, doesn't it?
For me, it does.
Yeah. Wow, this is very, very good. Peter, thanks for giving us a breakdown of this Pareto problem that's hit AI. We are looking forward to you following us. We'll drop the links that we just showed on our screen in the description. And thank you for being involved in another episode of Practical AI.